So we'll go over NFL Week 6 prediction. So currently we're 11 and 14, a bit below 50%, but Bills 4.5 against the Falcons. Falcons have already done SNF upset, so that's why we have Bills minus 4.5, Raiders minus 4.5. This is one of those trends where if a team is lost by more than 30 points or more than 20 points and they're coming back as a favorite, Commanders 4.5. This is with the Chicago upset recently. I think a couple weeks back, a 325 game, so unlikely to do it again. So that's why Commanders minus 4.5. Eagles 7.5 due to TNF and recent upsets. Last week, TNF upset. Bucks minus 3 due to 49ers recent upset. So unlikely that they'll do it again. So these are five picks, currently 11, 14. Hopefully we can get back to goal now is to get back to hopefully around 500 and then improve from there. Now we'll get into some ASTAM material. So I'll just go over a few notes, few high-level notes, few detailed notes on some specific topics that I've learned over the few practice exams that I've done. So when we're talking about new rates, you take whatever you increase the base rate by and you multiply that by the indicated relativity, and that becomes the new rate for that particular class. So you take whatever you have increased the base rate by, right? And you multiply that by the indicated relativities. These are the new relativities after we've adjusted for the loss experience, right? That is your new rate for that class. Now, if you do PI over PC, you will probably not get the same rate change as you want when you did uh, when you calculated the rate change, and that's because you're calculating the indicated relativities independently from when you calculated your rate change. So that's why PI over PC is not going to be the same. This represents the change in premium, which is the associated with the change in rates. And we have our off balance factor, which is indicated of average relativity over current average relativity. And you want to account for the different distribution of exposures, right? Different distribution of exposure. And that's why we have, if you have two different rating variables, right? That is why we have an average relativity that we have to adjust when we do losses over exposures, right? It's not just losses over exposures, but it's losses over exposures times your average relativity. And you have to do that because you have to adjust your exposures, right? So it's your average rate over your base rate. That is your average relativity. And you only and if you only have one rating variable, if you only have one rating variable, then you actually don't need to do those exposures. And then system is to get through the first draft pass of all the questions as quickly as possible. Very easy for you to get stuck in a frame of thinking, frame of mindset, and then hyper contemplate on that same question, and you're going to waste time. So, first goal is to get through the first pass of the question as quickly as you can. Mac model plots have been common, I would say, sort of in recent history, but you want to know standardized residuals represent the projected ultimate claims versus the actual ultimate claims, the difference between those. Those residuals should show no obvious pattern or no obvious trend. Chi-squared expected counts less than or equal to 5. If they're not less than or equal to 5, then you regroup to make it that they are less than or to make it so that they are at least 5. If they are less than 5, then chi-squared is not a good test to perform unless it explicitly states in the question that it's okay to have less than or equal to 5. But typically the rule is it's better for the test result in terms of the significance and how much you can trust it if it has at least 5 expected counts. Now, frequency severity models, we have a couple of different ways to do frequency severity. First way is you develop frequency and severity separately using CL. So you develop frequency first, right? You develop frequency using CL. You get the per claim severity by doing the cumulative severity over the frequency, right? That is your per claim severity, and then you can project those out by using CL. So now you have your projected severity, projected per claim severity. You multiply that by your frequency, and that is how you get the cumulative. That is how you get the cumulative claim payments. Now you can also do that through CL, right, in the beginning, but you adjust. So at a high level, you project frequency, right? First step is to project the frequency. Second step is to get the per claim severity, right? Third step is to, once you've gotten the per claim severity, develop those, right? So you have like your 1.2, you develop those, then you multiply those developed ones by the projected frequency to get your projected cumulative claim payments. So that's the first way. Second way is to convert them into incremental first. So you convert the cumulative claim payments to incremental, right? You divide those by the number of claims settled to get your average incremental cost per settled claim. And then you take the average of that by each DY, and then you get your estimated number of claims to be settled times your average severity equals your outstanding claims. So typically, the second way is the preferred way, but I have seen questions in practice exams where the first way, if you were to do the first way, they would tell you in the question to do it the first way, where you develop the frequency and individual severity separately and then multiply them together. And then n-fold convolution is essentially the same thing as expected value, but you're taking the frequency, you're taking the severity, and then you're saying, okay, what's the probability that the sum of all these severities is this amount, given that the frequency is this, product of all of that across all possible frequency values. So it's the expected value, but it's just in a different format. It's the sum product of the probability that it equals that aggregate amount given the end across all ends. Net stop loss premium, if it's a deductible, it means an aggregate deductible, and then get through first pass of the exam as quickly as possible. Frequency severity drawbacks, very, very complex, may require more data. CL doesn't work well when you're trying to project out the frequency. It's not a very good technique for frequency counts. And try to solve as many questions using Excel as possible to try to sort of skip a lot of the many mistakes that you might do when you're trying to hand calc it. Kolmogorov-Smirnov only works with individual data points, right? Individual data points. Group data points is very good for chi-squared. Now, when you're doing inflation adjustment for CL, there's 3 different steps, and you want to make sure you don't forget any of this. First is you adjust the previous incremental, right? Previous incremental to the current. So you do QI over QI plus J. Okay, so if it's 10 2 years before, then now it would be obviously a lot. So you would obviously your QI or your current would be greater than your QI plus J, so something like 107 over 105, and then you convert those to cumulative. Then you do your entire CL. Then you convert the projected cumulatives back into the incremental cumulative. So you get, in other words, your projected incrementals. And then you want to convert those projected incrementals, right, that you've projected back into current. And so now this is like your 105 over 107. You're taking that 2 years from now, and then you're converting it to today's value, right? Which would be multiplying it by less than 1. And then R is number of policyholders/groups, N is number of years observed. Variance of theta is the Kramer-Rao lower bound, and if it is the Kramer-Rao lower bound, then it is the lowest variance among all unbiased estimators. And this is just a theorem you should know, that if it is the inverse of the Fisher information, right, that is the asymptotic variance. Inverse of the Fisher information, asymptotic variance, is a Kramer-Rao. If you get the variance to equal that, that is the lowest variance. That has the lowest variance among all unbiased estimators. So that is a way to prove it. Compound Poisson processes. Commonly asked question is when you have multiple collective risk models where the frequency follows a Poisson and the severity follows a certain distribution. So if you have all of these different, let's say, portfolios, let's say you have n portfolios, each portfolio has a frequency and a severity distribution, so x1 to xn. The aggregate frequency is Poisson, this and the sum of all the lambdas, which is pretty right common. We know that's the case. Sum of Poisson is also Poisson with the summation of the lambdas. That is your aggregate frequency. Then the single severity. So this is a way to combine all those severities. Is the proportion, is the summation of the all of the severities, and each of them has a weight, and that weight is associated with that particular lambda of the frequency over the total summation of the lambdas, or the total aggregate frequency mean. Okay, so that is a single severity. So again, what is this? You have n different portfolios. Each of those portfolios has a frequency and a severity distribution. So it's a way to combine many different collective risk models, many different frequency and severity combinations into a single frequency and severity combination. Expect payment per loss. Now this is when we're doing payment per or payment per payment. When we're doing payment per payment, it's payment per loss over the probability that that payment even occurs. So it's not just okay, if we do something to calculate YL, do we also have to do something in the denom? Denom, you should always think of it as probability of making the single payment, right? What is the probability of making the single payment? So if it is a policy limit, as of the denom is just one, right? Because you will always make the payment, right? But if it is a deductible, then it's a probability that X is greater than the deductible because you will not always make up the payment. So that is a key thing. Expected value of YL over SSD. And then be discrete and have clarity on the two ways to approach a problem. Sometimes if you go through a question, you may have two different ways and you're sort of just mentally stuck, but make it clear and see, okay, these are the two ways of going about this problem. What is the best way of going about this? Right? The more clarity that you're able to sort of like verbalize and put out onto the paper, it makes your thought process more coherent and clear, and you're able to think more clearly in terms of like which method to actually go and take moving forward. Goal seek, when you're trying to set the derivative of log likelihood to be zero, so you want to set the target value to be zero. What do you want to set the target value to be zero? Well, it's the derivative of the log likelihood. You want to maximize it. So that's how you find the critical points there, right? And always typically whenever there's a goal seek question and you're trying to it asks you to get the individual values, always use the actual PDF notations instead of trying to plug in the natural logs. And then if there is a trended loss question, you want to understand that the first number that is what you're beginning with. So ultimate losses equals 2206 plus MT. You're starting with the 2206, and then your MT represents over time how much you increment that by. So the 2206 is the intercept, and then you natural log transform the y, and then the t stays the same, right? That is how you get the ultimate loss equals 2206 e to the mt. And sometimes differentials, when you have differentials, and you may not just be referring to a single class, right? It's not just two different differentials in a single class. It's actually two different classes itself. So you always want to remember that it's expected insured payment over the expected insured payment under a different class. So it's insured payment under class A over class B. So it's two different classes instead of just thinking it's one class and it's two separate deducts. It's actually two separate classes, and you have to make sure that it's the expected payment, right? Or the expected loss, depending on what you're solving for, or yeah, expected payment per loss. If you and then sometimes if you have Poisson frequency and or even any frequency distribution, AB0 distribution, and you have zeros as an option in the severity, it's going to be way easier to actually change that frequency, modify it so that it includes the zero. So you can think of this as like changing a Poisson frequency to be number of payments, and you do Poisson mean of that, right? Poisson lambda times the probability it's greater than D, right? You change it to that, and then that is how you can make calculation of the probabilities a lot easier. So you change the Poisson frequency to include the zero. So it's the frequency, lambda, right? Your lambda times the probability, it's zero. Right, so that is how you will incorporate the zero in to your frequency, and then so then your severities are anything but zero, right? All everything but zero, which is going to make calculating aggregate probabilities a lot easier because you have less possibilities to account for. You can't have like five different losses and then all of them are zero, right? So because you've set the frequency that way, it becomes a lot easier. So those are some key tips. And then, as I mentioned, I feel like the main thing is to get through a first pass of all the questions as quickly as you can. If you're even hesitant on a single question, move on and get through a single pass of of all the questions probably in like less than 2 hours. So you have time to go back and really refine your approach and your work. And again, try to use Excel as much as possible when you're doing these calcs. And for the first pass, don't like you want to show all your work, but don't try to overemphasize. Don't overemphasize on showing every single little detail. You want to leave that towards the end and on adding detail and adding clarity. So those are some tips I've learned over a couple of these practice exams.